week, we will explore the three options that we have for addressing climate change: mitigation, adaptation, and geoengineering. First, mitigation is reducing fossil fuels, which to date we have been quite unsuccessful at. So we will consider ways that governments could gently encourage reducing fossil fuels. We'll talk about carbon taxes and cap and trade. Second, adaptation. These are actions taken to reduce the risk from climate change. Last week, you watched a short video about actions being taken by the mayor of Miami Beach to avoid risks posed to the city by rising sea levels. These are all examples of adaptation. Last, geoengineering. This group is highly controversial among scientists and involves two main groups. The first is solar radiation management, and the second, negative emission technology. Geoengineering involves human tinkering with the climate system, and in the case of the latter, also the carbon cycle. The aim of these three strategies, mitigation, adaptation, and geoengineering, is to avoid the consequences of dangerous anthropogenic interference of the climate system. This slide serves as a reminder of what we learned in Lecture 7. This slide shows our options for emissions. It shows how the cumulative total global emissions will vary and the consequential rise in temperature under different emission scenarios. The black line shows what has happened until 2010. Each colored line represents a different emission scenario. The pathway we need to be on to avoid dangerous anthropogenic interference with the climate system is the RCP 2.6, the line shown in dark blue. Note the large differences in where we end up in 2100 following the different pathways. So what are we going to do to avoid dangerous anthropogenic interference of the climate system? What are the options for addressing climate change? This slide provides a quick review of the problem on the top panel and possible solutions on the bottom panel. You'll notice the possible solutions include mitigation, which is really reducing our emissions of greenhouse gases. And on the far right, we see adaptation. The two in the middle, carbon dioxide removal and solar radiation management, are both examples of geoengineering. Although some people would consider them mitigation and adaptation, I think they deserve their own special classification and consideration. The UN's position is clear. There is no substitute for dramatic reductions in the emissions of carbon dioxide and greenhouse gases. This is what we did as individuals during the climate change challenge, and what many governments are trying to do on much larger scales. As we learned in Lecture 7, increasing energy efficiency has helped, but it's not enough. We have to do more. In order to target success, we first need to think about why we haven't been more successful at reducing emissions. Although it might be tempting to blame individuals or companies, climate change is really a system problem, and it means that we need a system solution. Individuals can instigate and drive change, but we need governments and businesses to make the systematic changes that will ultimately put us on the right path. Economists recommend adding a cost to burning fossil fuels in line with the true costs to the environment and society. In 2018, two American economists who had been working on ways to include environment and social costs won the Nobel Prize for Economic Scientists. One of them, Paul Romer, was interviewed on CBC Radio and made these comments about carbon taxes. There are two ways to add a cost to emitting fossil fuels. First, you can tax emissions. This is referred to as a carbon tax. Here, you pay for what you emit. Secondly, you can regulate emissions. This is referred to as cap and trade. Here, the government decides how much you can emit, and you can purchase rights to emit more.